So the copper sulfate, as you see, when it has the sodium hydroxide, it becomes cloudy, and we get this precipitate that's made. In fact, I can add some more. You can kind of tell that's cloudy, right? Can you? Yeah, this you can see through, that you can't see through too much. This has it's kind of what we call a floc, F-L-O-C, where it's a suspension. It never does settle down to the bottom. Usually a precipitate will just settle after a while. Now, this is a treat for you. This is now, we've created an insoluble copper hydroxide, and I can shake it. I can hope that it'll dissolve. It's just not going to dissolve. If I add a ligand to it, the ammonia molecule, now this is 10 molar ammonia. Very tempting for me to offer this up to you to smell. But I'm just going to add a couple of drops of the 10 molar ammonia. Check this out. This is so good. So I'm just going to let it sit there, not shake it or anything. And what do you see? You guys that are close to it can see it. It turns a different color. And not only does it turn a different color, it becomes transparent again. So where it is a different color, there is no solid. And then in the bottom half, or the bottom 7/8 of it, is still cloudy. And when I shake it up, I didn't add quite enough ammonia. So I'm going to just give it a couple more drops of ammonia to it. Okay, I'm going to let it just settle in again some. And now we're going to have that thicker layer of the darker blue color of the part that the ammonia is in. Now, stirring this baby in. May have to add a little bit more. I will. But we can see, if you're close to it especially, the precipitate is getting kind of chewed up and it's not as dark anymore, not as cloudy. Now, if I just hit this with a good bit of ammonia, look at that color. That is a beautiful color. This is the copper ammonia complex ion. That first slide where I showed you the ammonia from like 4 sides adding to the copper, that's what that is. So it takes this copper ion, which is just copper plus 2 aqueous, and makes it CuNH3 taken 4 times aqueous. And what you probably can't really appreciate from where you're sitting is, even though this is a very deep blue color, it is totally transparent. I could hold something up behind it and read what is behind it. It has caused the solid copper hydroxide to completely get dissolved. And not only does it dissolve, it turns this great color. So that is what happens when you have a complex ion that forms. The complex ion becomes very soluble and just dissolves away on it. Here's another example. Silver ion. The silver ion is in here. This is silver nitrate. Silver is photosensitive, so if we let the light hit it for too long, it starts to make it all black, and it oxidizes because of the light. So we keep a paper towel over it to keep light from hitting it. This is silver nitrate. If I add my little bit of hydroxide, it makes the very obnoxious brown precipitate. Oh boy. There it is. Brown precipitate, silver hydroxide. Now, once again, if we come in with our 10 molar ammonia, very high concentration of ligand, just like we saw up there, if I can have you just turn around and look at this thing, that second equation, that little bit of silver ion that's dissolved in this brown is going to take some of those ammonia molecules and make the silver ammonia complex. Let's check it out. This is so great. All right, watch this now. A couple of drops of the ammonia, maybe just 3 or 4 at the beginning. And once again, before I shake, you can see that top layer where the ammonia is now dissolving all the brown. It's not just pushing the brown down. It's kind of what it looks like. It's just pushing it down. Nope. If I just give that a little shake. Oh, I love this. Keep working on it. And that ammonia, over time, not even that much, just like 5 drops of it. Oh yeah. And that brown is gone. That silver hydroxide all dissolved because of the production of the silver ammonia complex. And this doesn't have a great new color to it, it just goes clear, but all that nasty, obnoxious brown has been dissolved. One more example. This example is not as impressive with the colors as the silver and the copper are, but this is a good one too, because I'm not going to use my ammonia at all. I have aluminum this time. This is aluminum nitrate. I need to add a pretty decent amount. This is dilute sodium hydroxide. So I'm going to add just several drops of the sodium hydroxide. And you probably, hopefully can see it. It turns like into a white flock kind of precipitate. I'll add a little bit more. Can you tell that it's cloudy?
Yeah.
It is. Now, this is aluminum hydroxide that has made a precipitate. Kind of a weak precipitate. It almost still looks like it's dissolved. I'll add some more. If I take now a more concentrated hydroxide, this also is sodium hydroxide, but this time it's 1.5 molar. So this that I added to make the precipitate is 0.1 molar. And then I'm going to add a high concentration of hydroxide. I'll just pour it in, but just a tiny amount of it. I'll do it up above so you can see it going in there. So the same stuff, but a higher concentration. Don't make a fool out of me now, hydroxide. I need a little bit more. You see that it's cloudy, right? Same stuff. I love it. Precipitate is gone. So a little bit of hydroxide with aluminum will make a precipitate, but a high concentration of the hydroxide will cause a complex ion to form, and all that precipitate that was there from the same stuff has dissolved. That is so good. All right. So this is the way complex ions work. And on my next slide up there, thanks, Rishi, for holding that. So did you just turn it back on?
I just started recording.
Here's the star of the show, right there. Thank you, Rishi. You're a hero. Okay, so on this slide, what we see is 2 different ways that we can increase solubility of things that are stubborn about dissolving. Number 1, if you can't get something to dissolve, but you want it to, you can add acid. As long as the anion is basic, the acid will help. The acid will dissolve. The other thing is, if you have something that is stubborn about dissolving, and the metal is a transition ion metal, or a transition metal ion, then you could try to make a complex ion. With ammonia, with hydroxide. We'll see in the next example with cyanide ion works as a ligand. So there's a number of things that you can do to make complex ions, a number of ligands that you can choose from. I asked you to put that away. Looks so good. I don't want any. I want it. Yes, I want it.
You should have one. Okay.
Isn't that?
Okay, with just a little bit of time left this hour, would you try one more complex ion problem? This one, I want you to model after the one that we just did together before I went to the back of the room. This is a very similar kind of problem. See if you can get through this and determine the solubility of the silver in cyanide. Hopefully you are at least to the point where you have written the chemical equations. I'm going to go ahead and put that part off.